I'm in water resources engineering, which is under the Department of Civil and Environmental Engineering. My project works with pier scour. Right now, around up to 60% of bridges are failing because of processes involving river hydraulics, and scouring is one of these processes. Scouring is when a sediment is being moved by the water. So let's say you have a block or something like a pier, and you have the sediment around it. So the sediment around it keeps it stable. So when the water is flowing around it, if the water is flowing too quickly, it can pick up the sediment and move it somewhere else. So once you have that happening, this erosion occurs, and that's what the scouring is. So generally, when people build bridges, they build them in constricting areas, and this saves money because you'd have to have less material costs. So when you have a constricting area, there's actually two types of processes that can cause erosion. There's the scouring that's caused by the pier itself. So the water is moving around this pier and it's kind of eroding away at the pier. And then you have the scouring that's caused by the acceleration of the water due to the narrowing of the river. I have a flume over here, and I basically have a pier, so that just represents the pier of the bridge, and I have sand, so I have, and I've also got water flowing through it. So in that case, it pretty much represents a river. So if I have the pier and the river, that just represents a bridge in just kind of normal conditions. And then I have these side things that represent these constrictions. So there have been some tests done, experiments like mine, but no one's really combined the two cases of having a river that's narrowing as well as building a bridge in this case. So there are methods of looking at this, and they usually take the two types of erosion separately: the erosion that's caused by the narrowing and the erosion that's caused by the bridge itself. But no one's really looked at both of these cases together, and this is a pretty common occurrence. So that's one of the reasons why these bridges aren't doing so well. So I think that's a practical application of my research.